Alright, this is lesson 2.8, proving angle relationships, and on numbers 1 through 4 the directions say find the measure of each numbered angle and name the theorems that justify your work. So for number 1, the measure of angle 2 we are given equals 26. So based off of that we know that 1 is 90 because we have the right angle symbol, so we can find the measure of angle 3. The angles 2 and 3 are complementary, or adjacent angles that form a right angle. So the theorem that we would use here is the complements theorem, which states basically this, that if two angles are adjacent and form a right angle, then they're complementary. So based off of that, we know that we have a right angle here because angle 1 is a right angle, and 2 and 3 are adjacent, or they share this side. So they have to add up to 90. So we set up our equation, the measure of 2 plus the measure of 3 is equal to 90. From there we substitute in 26 for the measure of angle 2 plus the measure of 3 equals 90. Then we subtract 26 from both sides, so we get the measure of angle 3 is equal to 64 degrees. So once again the complement theorem has been used in this case, which states that if two angles are adjacent and they form a right angle, then they will be complementary. For number 3, we're given the measure of 4 is 2x and the measure of 5 is x plus 9. So by the supplements theorem, we know that these two angles will be supplementary. The supplements theorem basically states that if you have two adjacent angles that form a linear pair, then they are supplementary. So then they add up to 180. So we know that these are a linear pair because they're adjacent, they share this side, and they're non-shared sides, so angle 4 side, angle 5 side, those two sides together form a straight line. So we can state this, the angles 4 and 5 are supplementary or form a linear pair. So 4 plus 5 is 180. Then we substitute in, so 4 is 2x, 5 is x plus 9, set it all equal to 180, combine your like terms, and you get 3x. Subtract 9 from both sides and you get 3x is equal to 171. Divide both sides by 3 and you get x is equal to 57. From here we have to find the measures of 4 and 5, so we have to substitute 57 back in for x into these two expressions. So x is equal to 57 and the measure of 4 equals 2x. We have 2 times 57 or 114. The measure of 5 is x plus 9, so there we have 57 plus 9, or 66. So once again, the supplement theorem has been used. If two angles are adjacent and they form a linear pair, then they will be supplementary. In number 5, refer to the diagram of the parking lot. Given that angle 2 is congruent to angle 6, prove that angle 4 is congruent to angle 8. So these two angles are congruent if these two are. So in our proof, we state our given information and what we want to prove, and then we start listing in a 2-column proof statements and reasons for the statements. So it's always good to start off with some given information. So angle 2 is congruent to angle 6. That is given. That's our reason. From here we can also make some true statements based off of linear pairs. So we know that 2 and 4 form a linear pair, so they'll be supplementary by the supplements theorem. Also 6 and 8. So we can say that the measure of angle 2 plus the measure of angle 4 equals 180, and the measure of angle 6 plus the measure of angle 8 equals 180. And that's the supplements theorem. Linear pairs are supplementary. From here, and the goal here is to prove that 4 is congruent to 8. So we're going to use some substitution. We want to get some equivalent expressions in our equation so that we can substitute various expressions into other equations. So we're going to start moving some things around. So we know that 2 and 6 are congruent, so I can swap them in and out for each other. So if I take this second statement, take 6 out and put 2 in its place, I get the measure of angle 2 plus the measure of angle 8 equals 180. So that's by substitution. Now from here, we have 2 plus 4 is 180, and 2 plus 8 is 180. We want to get 4 and 8 by themselves, and we want to get them equaling the same thing. So we could subtract the measure of angle 2 from both sides, and then 4 would be by itself, and 8 would be by itself. So that's what we're going to do next. We're going to take this equation and subtract the measure of angle 2 from both sides. We're going to take this equation and subtract the measure of angle 2 from both sides. Okay, so that's by the subtraction property of equality. Once we do that, we get the measure of angle 4 equals 180 minus the measure of angle 2, and the measure of angle 8 equals 180 minus the measure of angle 2. Now we have the measure of 4 and 8 equaling the same thing, so we can do some more substitution. We can set those equal to each other because they're both equal to 180 minus the measure of angle 2. So in our next step, substitution. Measure of 4 is equal to measure of 8. And then finally, anytime two things have the same measure, they're called congruent. So if the measure of 4 is equal to the measure of 8, then angle 4 is congruent to angle 8 by the definition of congruent angles. At this time, try some problems on page 156, numbers 1 through 7, odds. Take about 5 minutes or so to look at those problems. In number 7, we want to write a 2-column proof given that angle 4 is congruent to angle 7. So given that these two angles are congruent, we want to prove that 5 is congruent to 6, that these two angles are congruent. So we are given 4 is congruent to 7. We want to prove that 5 is congruent to 6. So let's go ahead and state our given information that 4 is congruent to 7. Also, we have some vertical angles here in our diagram. So we can state that those are congruent. Always when you see vertical angles, chances are that you're going to use those in your proof somewhere. So go ahead and state that 4 is congruent to 5 and 6 is congruent to 7 by the vertical angles theorem. From there, we can use some substitution. So we want to arrive at this conclusion that 5 is congruent to 6. So to get us closer there, we can say that 7 is congruent to 5 because we know that 4 and 7 are congruent. We know that 4 and 5 are congruent. Since 4 and 7 are congruent, I can put 7 in place of 4. So in this statement right here, I take 4 out and I put 7 in its place, and I get this new statement. 7 is congruent to 5. Further on, we substitute again. So we want to arrive at this conclusion that 5 is congruent to 6. So we have that 7 is congruent to 5. Earlier we said that 6 is congruent to 7, so I could put 6 in place of 7. So let's take 7 out in this step. Let's put 6 in its place, and now we have 6 is congruent to 5, which is the same as saying 5 is congruent to 6. So through substitution, we proved that 5 is congruent to 6 if 4 is congruent to 7 in this diagram. So in the next set of problems, numbers 8 through 13, we want to find the measure of each numbered angle, name the theorems used that justify your work. So in number 9, angle 2 and 3 are complementary, so they will add up to 90. 1 is congruent to 4, and the measure of 2 is 28. So the first thing that we can do, since we know that 2 and 3 are complementary, we can say that the measure of 2 plus the measure of angle 3 equals 90. Then we will substitute in what the measure of angle 2 is. We are given that it equals 28. So 28 plus the measure of 3 equals 90. So subtract 28 from both sides, and the measure of angle 3 is 62. From here, we have a straight line. So by the supplementary angles theorem, we know that 1 plus 2 plus 3 plus 4, those 4 angles all have to add up to straight line 180 degrees. So that's what we have there. Then we're going to substitute in. We know that 2 and 3 are complementary, so 2 and 3 we can substitute in 90 for. So 1 plus 90 plus the measure of angle 4 is equal to 180. Now from here, we can subtract 90 from both sides. So the measure of 1 plus the measure of angle 4 equals 90. And since we know that 1 and 4 are congruent, that's what it said earlier on, then saying 1 plus 4 is the same as saying 1 plus 1 is 90. So 1 plus the measure of 4 is 90, 1 plus the measure of 1 is 90. And from there, combining like terms, we get 2 times the measure of 1 equals 90, and we divide by 2, so the measure of angle 1 is equal to 45. So the measure of angle 1 is equal to 45, and the measure of 4 is equal to 45. And these steps right here show the congruent complements theorem. So 2 angles that are complementary with the same angle will be congruent. On number 11, the measure of 9 is 3x plus 12, and the measure of 10 is x minus 24. So these 2 angles are a linear pair. They share this side, their non-shared sides is a straight line. So by the supplements theorem, they will be supplementary. So that's the theorem that we'll use here, the supplements theorem. So the angles 9 and 10 are supplementary or form a linear pair. So the measure of 9 plus the measure of 10 is 180. So we substitute in for 9, which is 3x plus 12, and 10, which is x minus 24, into this equation. We combine our like terms, so that would give us 4x plus 12 minus 24 would give us minus 12. We add 12 to both sides, so we get 4x is equal to 192, and we divide both sides by 4, so we get x is equal to 48. Our last step is to substitute back in 48 in place of x. So the measure of angle 9 is 3x plus 12, and the measure of 10 is x minus 24. So when we substitute in, the measure of 9 becomes 3 times 48 plus 12, which is 156. And 10 becomes 48 minus 24, which is 24. So once again, we use the supplement theorem on this problem. On number 13, the measure of angle 6 is 2x minus 21. The measure of angle 7 is 3x minus 34. So the 2 theorems that we'll need to use here are the supplements theorem. So we have a linear pair, 6 and 7 form a linear pair. They are adjacent. Non-adjacent sides is a straight line. So the measure of 6 plus the measure of 7 is equal to 180. The other theorem that we'll use is the vertical angles theorem. So 6 and 8 are congruent because they are vertical angles. So the first part, 6 plus 7 is 180, the supplements theorem. So we substitute in let's see, what was that? The expression for the measure of 6 and the expression for the measure of 7. We add those 2 expressions together, set it equal to 180. We combine our like terms. 2x and 3x is 5x, minus 21 and minus 34 is minus 55. We add 55 to both sides, we get 5x is equal to 235. We divide both sides by 5, and we get x is equal to 47. So we substitute x equals 47 in for the measure of angle 6, 2x minus 21. So that gives us 2 times 47 minus 21, which is 73. And once again, since 6 and 8, if we go back to our diagram, 6 and 8 are vertical angles, they are congruent. So if the measure of angle 6 is 73, the measure of angle 8 is 73. And once again, going back to our supplements theorem, 6 and 7 have to add up to 180. So if we substitute in to this equation, we can find the measure of angle 7. The measure of 6 is 73, so subtract 73 from 180, and the measure of angle 7 is 103 degrees. So we use the supplements theorem and the vertical angles theorem. So on number 15, we want to write a 2-column proof. Statements and reasons. We are given that 5 is congruent to 6. So angles 5 and 6 are congruent. We want to prove that angles 4 and 6 are supplementary, that they add up to 180. So just looking at our diagram, we know that 4 and 5 are supplementary because they're a linear pair. And if 5 and 6 are congruent, then we can very easily show that 4 and 6 are supplementary through substitution. So that's kind of the plan that we'll use for this proof. So we go ahead and start the proof off by stating our given information, and in my answer here I had to make some changes. So it did say 4 is congruent to 6, which is incorrect, so I changed this. Hopefully you can follow along. So on 1 we state our given information that 5 is congruent to 6. From there we can use the definition of congruent angles to say that the measure of angle 5 is equal to the measure of angle 6, since they are congruent angles. From here we want to use the supplement theorem and say that 4 plus 5 is equal to 180 because 4 and 5 form a linear pair. Now we can use some substitution because ultimately we want to arrive at the fact that 4 and 6 are supplementary. So since we know that 5 and 6 are equal in measure, then I can substitute them in for each other. So if I take this expression, instead of it reading 4 plus 5, how about let's take 5 out and put 6 in its place. So instead of 4 plus 5, let's have 4 plus 6. And that's what we have in the next step. So angle 6 plus angle 4 is 180. And if they add up to 180, then we get to say that they're supplementary. So angle 4 and angle 6 are supplementary. And the reason for this is because they add up to 180, which is the definition of supplementary angles. If you look up the definition of supplementary angles, it says two angles that have a sum of 180 degrees. So if you can show that in your proof, then you can state that two angles are supplementary by that definition. And right now would be a good time to try out problems 8 through 14 evens on page 156. Take about 5 minutes to look over those problems at this time. So on the next problem, on number 17, we want to write a proof for each theorem. We want to write a proof for the complement theorem. The complement theorem states that if two adjacent angles form a right angle, then they will be complementary. So we want to make a diagram similar to what we would see on the page in our book where the complements theorem is found. And then we want to state our information. So we are given that angle ABC is a right angle. We want to prove that these two angles that form angle ABC are complementary. So we start by stating our given information. Angle ABC is a right angle. By the definition of a right angle, we can state that the measure of ABC is equal to 90 degrees. And these two steps, you could put definition of a right angle in either case. It's a biconditional statement. So if it's stated first that the measure of ABC equals 90, and then second that angle ABC is a right angle, then we would still put definition of a right angle as our reason. So anyways, the next thing that we want to say is that the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. So if I add this measure and this measure together, I should get this entire measure. And that's the angle addition postulate, which is very similar to the segment addition postulate. If you add two smaller lengths together, then you get the entire length. So from here, we just need to do some substitution. So once again, we're trying to prove that 1 and 2 are complementary. So if we can show that they add up to 90, then we know that they're complementary. So in our next step, sorry about that, I had to pause because my daughter came in the room, but hopefully I remember where I was at here. So in the next step, we're going to substitute in 90 in place of the measure of angle ABC to get this next statement. So the measure of angle 1 plus the measure of angle 2 is equal to 90. From here, we can now state that angles 1 and 2 are complementary by the definition of complementary angles, because we just showed that the measures of 1 and 2 have a sum of 90 degrees. In number 19, we want to write a proof for the transitive property of angle congruence. So, the transitive property of angle congruence states that if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. So we start by stating our given information. From there, we can state that since the angles are congruent, then they will have equal measures. So the measure of 1 is equal to the measure of 2. Measure of 2 is equal to the measure of angle 3, and that's by definition of congruent angles. From here, we just use the transitive property of equality. So I'll write that here, of equality. Which states that if A is equal to B and B is equal to C, then A is equal to C, which is what we have right here. So 1 is equal to 2, 2 is equal to 3, therefore 1 is equal to 3. And then from here, it's just another application of definition of congruent angles. So since we've just proved that the measures of 1 and 3 are equal, then we can say that angles 1 and 3 are congruent.